All right, guys, if you look at this worksheet, those questions with the red dot, those are actually on our notes, right? So number 1 was on our notes, number 3 was on our notes, number 5, number 11, number 13. And you are doing the odd ones only on this worksheet. On my worksheet, I deleted the even ones. You still have them on there, but we're only doing the odd ones. You're assigned only the odd ones. So let's all take a look at number 2, since that was not on the notes. How do we do this? How do we start graphing this? Find the vertex. So everybody write down V, coordinate, formula, x equals negative b over 2 times a. Use parentheses, negative parenthesis over 2 times parenthesis. Your b value is 6, your a value is 1, your c value is 6. So plug in 6 for b, 1 for a. You end up with negative 6 over 2, which equals negative 3. So we have the x value of our vertex, negative 3. And we're going to plug in that negative 3 into the x's to find the y value. Again, we're kind of like pretending if it were an equation. So instead of x squared, I put parentheses squared plus 6 times parentheses plus 6. And we are plugging in the x value of negative 3 right in there. And when you do the math, negative 3 squared is 9. 6 times negative 3 is negative 18. And plus 6 at the very end, your final answer will be negative 3 if you do the math correctly. So the vertex is negative 3, negative 3. Let's go to that most important point of negative 3, negative 1, 2, 3, and put a dot right there. Are you with me? Yes. What do you do after drawing the vertex? You draw your axis of symmetry, vertical line right through it. And could we use a pattern on this one? Yes. What is the pattern?
1, 1, 4, 9.
So from the vertex, 1 over 1 up, put a dot right there. Probably should have gone red. Back to the vertex, 2 over 1, 2, 3, 4 up, put a dot right there. Back to the vertex, 3 over 1, 2, 3, 3, 4, 5, 6, 7, 8, 9. I'm off the graph. I don't need to plot it if it's off the graph. But let's map them over to the other side, here and here. Now, is this parabola going to be solid or dotted?
Dotted.
Dotted. So let's do dotted parabola. Put some arrows on it. And you're either going to shade in the inside or the outside by testing a point, determine your answers. Easiest point to test is 0, 0. Plug in 0 everywhere. 0 for y, 0 for x's. It's going to say 0 is greater than 6. Is 0 greater than 6?
No.
Heck no. So this guy's a no-no. No, it doesn't work. So where are your answers at?
Inside.
Inside. So I want to shade in by highlighting the inside of the parabola. Highlighting the inside of the parabola. There you go. Any point on the inside will work, right? Now, there is a big difference between graphing, where you have to do the precise parabola, solid or dotted, shading inside or outside, as opposed to these guys down here, where there is no y involved. It's just solving for x. So I do want you to think of the graph, but all you have to do is focus in on the x number line to determine if it's between these two or apart. So that's what we're going to be doing down here on the bottom ones, right? So 5 is already on our notes. We could do 7 or 9. Pick one. 7? I think actually was 9 on the notes?
Yes.
I think so. 9 was on the notes also, right? So we already did 9 on the notes as well. So let's look at number 7. I could factor this guy. Pretend it's an equation. What times what is negative 20 that if you combine together is negative 1? What times what is c that if you combine together is b? Come on, people. What times what is c?
4 and 5.
4 and 5. Which one's positive, which one's negative?
4 is positive and 5 is negative.
Yep. 5 is negative, 4 is positive. Now that you've factored it, you could split it and solve. X minus 5 equals 0. X plus 4 equals 0. Solve both of them. You're going to get one answer of 5. You're going to get the other answer of negative 4. I'm not showing my work, but those are the answers. So if it were a regular equation, I would be done right there. But it's not a regular equation. So we're going to go to an x number line. X-axis. We're going to plot the answers. Let's say negative 4 is over here. Positive 5 is on the right side. Where's 0 at? In between. Somewhere in here. So let's draw our y-axis somewhere in there, right? That doesn't have to be perfect. It's just a sketch. Is this parabola opening up or down? Up. So the vertex has to be somewhere down here, right? And it's opening up. And just for the sake of being consistent, it is going to be a dotted parabola because there's no solid line underneath it. So let's just do a sketch of a dotted parabola like this. It's just a sketch, nowhere near accurate. I mean, minus these are the locations of where it crosses, but everything else is slightly inaccurate. But anyways, are our answers on the inside or the outside? I need to test a value. What value am I going to test? 0, 0. Excited, huh? Okay, so plug in 0 everywhere. Here's 0 squared or minus 1 minus 0. You're going to end up with negative 20s being greater than 0. Is negative 20 greater than 0? No. So this did not work. Where are your answers at? Outside. So you would be shading in the outside, ladies and gentlemen. You'd be shading in everything out here. Now, this equation, this inequality, I'm sorry, didn't even have y's involved. So we're just going to look at the x number line. And just looking at that x number line, our answers are that way and that way. So it's going to be a part with the word or between it. So what are we going to say? X is less than negative 4 or x is greater than positive 5. That's our complete answer for that question right there. Again, we're using our knowledge of parabolas and the different values that a quadratic has to be able to sketch the parabola without a graphing calculator. And then once you have it sketched, just focus on your x's and determine if your areas are together or apart. Right here it's apart, so you write them apart with the word or between it. Shall we do another? Pick one, 15 or 17 since the rest. 17, all right. So what do I do first? If this were an equation, what would I do? Subtract 27, x. Subtract 27, x. Let's rewrite it. 5x squared minus 27x plus 10. We're going to pretend it's equal to 0. Now, we could try to factor, split, and solve, but the a value is other than 1, which means we have the a times c situation. If you want, let's go with the quadratic formula. So we're going to plug in our b value of negative 27 right in there and right in here. We're going to plug in our a value of 5 right here and right there, and plug in our c value of 10 right here at the very end. So we need a calculator, guys. Help me out. Get a calculator and go ahead and do negative 27 squared in parentheses. It's going to be just 27 squared. What's the answer there? 729? 729. Okay. So 27 squared is 729. A negative times a negative is a positive. How about 4 times 5? That's 20 times 10. That's 200. So I'm going to be subtracting 200 from the 729. So I will have positive 27 plus or minus the square root of 529. Question, is the square root of 529 a perfect square number? Could you do the square root of 529 on a calculator? It's still over 10, by the way. It's 23? Perfect. So we really have 27 plus or minus 23 over 10, which is really 27 plus 23 over 10, and it's also 27 minus 23 over 10. So 27 plus 23, that is 50. 50 over 10, that's 5. So one answer is 5. The other answer, 27 take away 23, that's 4 over 10, which reduces down to 2/5. So our two solutions are 5 and also 2/5. So those are our answers. If we actually went to an x-axis, an x number line, and plotted those two answers, here's 2/5. 5 is clearly bigger than 2/5. 0 is going to be on the left side of 2/5, right? So there's my y-axis. Here is 0. I know that this thing is opening up and it's pretty narrow. So it's going to the vertex is going to be way down here somewhere. Okay? So it is opening up. So you could sketch that if you want. It's a parabola that's way narrow, opening up. And we're either going to shade in the inside of the parabola or the outside of the parabola. So let's test 0, 0. 0, plug in everywhere. 0 squared is 0, 5 times 0 is 0, 0 plus 10 is 10, 27 times 0 is 0. 10 is greater than 0. Is that true or false? True. So this does work. 10 is greater than 0. It does work. So that means that everything on the outside is going to work. So your answers are going to be out here. So in terms of the x values only, you're at 2/5. Oh, I'm sorry. Let me change that to my pen. You're at 2/5. It's included because it is a solid line. You're at 2/5 and it's going this way. You're at 5 and it's going this way. So are we going to write this compound inequality together with the x in the middle or apart with the word or? That's right. So let's put x is less than or equal to 2/5 or x is greater than or equal to 5. That's your answer for number 17. Now, let's look at this last one, fencing. Okay, guys, I decided to delete 19. But let's take a look at number 15 here. 15 is interesting. First of all, pretend it's an equation, and let's get everything to the left side. So let's get rid of this 12x squared by subtracting 12x squared. And of course, you can't subtract it, so you're just going to rewrite it. It's a negative 12x squared is less than or equal to, negative 12x squared plus 9x is less than or equal to 0. And again, we are pretending that it's an equation, so let's get rid of those inequalities, put an equal sign right there. Now you could solve this using the quadratic formula where your a value is negative 12, your b value is 9, and your c value is 0. There is no c value. Or there's an easier way, there's a better tool that you could use, which is factoring, splitting, and solving. And what kind of factoring are we going to be doing? We're going to be pulling out the GCF. So the greatest common factor in both of these terms, there is x's in both, but there's also the multiple of 3 in both. So you could pull out a 3x or even a negative 3x. If you wanted to make this first term positive. So if we pull out a negative 3x, then we would have a positive 4x on the inside, and then plus, actually minus, not plus, it would be a minus 3, no x, right? Because negative 3x times 4x is negative 12x. Negative 3x times what gets you that 9x? That'd be a negative 3. Okay, so that was a little confusing because I pulled out the negative. You didn't have to do that. I did on this one. Well, the bottom line is you now have something times something equals 0. Something times something equals 0. So the first something could be equal to 0, and the second something could also be equal to 0. So when you divide by negative 3, 0 divided by any number, that's going to be 0. That's one answer. And over here, plus 3, you're going to end up with 4x equals 3. Final step would be to divide by 3, or divide by 4. And divide by 4, so your answer is x equals 3/4. So those are your two answers. Now, if this were an equation, this would be it. My two answers are 0 and 3/4. However, it's an inequality, a quadratic inequality. So we know we're talking about an area of answers, and the best way to determine where our area is to think of the quadratic equation once we put it in standard form, which would be this guy right here, okay? So the a value is negative 12, which means that it's opening down. But the bottom line is we need to go to an x number line, an x-axis, and let's plot our answers. The answer is 0. That's one of the answers right there at 0. And the other answer is 3/4. Now 3/4 is clearly going to be on the right side of 0. So that's another answer. So those are your two answers. We do know that this opens down and it's vertically stretched by 12. So it's a really narrow parabola opening down. Really narrow, right? Where's the y-axis, just for the kick of it? Okay, it's right here. The y-axis is right through that 0 anyway. So here we have a sketch of an xy plane. We do know that the parabola opens down. We know it's narrow. We know that it would be a solid parabola way up there and then comes back down. It goes this way. So the fact is we need to determine whether the answers are on one side of the parabola or on the other side of the parabola. They're either on the inside or the outside. So let's test the point. Now this one's different than the rest because on all of them we've been able to test the point 0, 0. And 0, 0 is either on the inside or the outside. This 0, 0 is actually on the parabola itself. So we need to pick a different x value to test. So we might as well test a nice number like 1, which is clearly out here, or -1, whatever you want. Let's pick a number that's on the outside, because to pick a number that's between 0 and 3/4, man, you'd have to do like 1/4 or maybe 1/2, and I don't want to be plugging in fractions. So let's either plug in a 1 or a -1. I'm going to plug in this green dot, which is at 1. So when I plug in a 1, either to this one or to the original, plug in a 1 here and a 1 there, you're going to get 9 is less than or equal to 1 squared is 1 times 12 is 12. Is 9 less than or equal to 12? Yes. 9 is definitely less than or equal to 12. So that means that this green dot out here is an answer. That means that all my answers are on the outside of the parabola. I shouldn't have gone this way, but on the outside of the parabola. Okay. So if I were actually graphing this inequality, I would be shading in everything on the outside of the parabola out here, everything on the outside, not on the inside. Okay. But then again, this is not a function that has y equals a quadratic trinomial. This is just x's. So we're just going to focus in just on the x number line, just on the x values. So what are our answers, and where are our answers? Are the answers between 0 and 3/4, or are they apart out here? Obviously they're apart out here. So you're going to have to write this as two separate inequalities. One would be x is less than 0, and then you have to use the word or. X is greater than 3/4. So there's your final answer, because the areas are out here. I'm sorry, this is a solid parabola. That means that it did have or equal to underneath the inequalities. So you have to have an or equal to on your answers as well. The original had an or equal to, that's why it was solid. And so we need or equal to's on our answers itself. All right, guys, I hope that this helps. I will be creating a quiz, cut and paste from this worksheet and from worksheet 4.7. Good luck.